Oh, there we go. All right. Welcome all. I've got one job today. Well, one job to start. And we've got to figure out the best way to get this guide working here. Here it was kind of tacked on, and I hate it. So, got to figure out a really nice way to constrain these two parts to just slide past one another. Pull-ups or longest handstand. Oh, don't have me do longest handstand. Give me like an amount of time to do a handstand, and I'll have to do it against the wall. I think. I don't think I can balance a handstand for very long at the moment, unfortunately. It's been a while since I've practiced that, but I should practice it more. Wait a minute. I totally forgot. This is supposed to go 5 up. And that means shoot. 1 minute handstand. Okay. I think I can do it. I think I can do it. It's probably a stretch, but you're right. That would be level 3. We got to make this a high goal though, because I don't know, man. I'll put it at I'll put it at 20 super chats, 5 and higher. No, that's too much. All right, it'll be $40. No, put it at $60. Level 3. 1 minute handstand. Oh gosh, that means I actually have to do it. That's so annoying. Booked a session. Well, let's see. Gotta remember to check my email. Blah, blah, blah. Booked a session for like a Monday, right? Yeah, great. Okay, looking forward to it. On KiCad. Very exciting. You can tell me right now. Chipped in 20 for a 2D session? No, it doesn't count. That's payment for goods and services. Come on. It's not tutoring. It's not tutoring session is $20 and I'll throw in a minute handstand. No. That's not how it works. No. Yeah, you can tell me right now what you're interested in doing in KiCad. I saw you doing some tutorials. I remember that, which looked like you were doing pretty well. Yeah, pretty funny. Good joke, good joke. Oh my god, I'm so unbelievably cooked. I didn't even know. I totally forgot about this. Oh, that sucks. Okay, I'm gonna have to go back to the old way. Unless. Unless. Okay. For now, designing a custom board. Fans, heating stuff, and include the BL Touch clone. Any cubic ran, but the extrusion was horrible and the leveling was shit. Okay. Okay. Fans, the heating stuff. So you're working on just the hot end, is that right? More like 3D modeling, how it will look. When you say BMG, what do you mean? Am I missing a term that I'm missing here? You're working on the hot end, okay. Sorry, I'm so gravelly today. My goodness. It all rests on the hot end. Do you have a filament dryer? If your extrusion was horrible, that might solve that problem. It's been huge for me. That's funny. I have a vision here, unfortunately, and usually that is a problem. Let's see. Yeah, filament dryer I would recommend. There's a lot of things that can improve your 3D printing experience. But if you don't have a filament dryer, you can use your oven. You just have to put at like a really low temperature and leave it there for like hours and hours. Goodness me. I have a dream here. Would it make your oven smell like plastic? Well, like you're not putting it at a temperature that's very high. You know, you want it to be like 100, 150 Fahrenheit, something like that. And I don't think it. I don't know. I used to do it. Now I have like a dedicated dryer that actually I like a lot. It's like 10. You might be the only one here, man. What is this, dude? Come on. Yeah, that's kind of what I was thinking. Am I overcomplicating this? Fuck. Have to go to work today at 4. Okay, that should be fun. I'm hopefully selling my car today. Jeez. This is so unnecessary. Come on, bro. Get real with me. It's just not worth the extra complexity to do what I want to do right now. Wait, no, that's what I want to do. Except it isn't. Except it isn't, because I want more space for the pressure vessel. Okay. So, here's what I have learned. Keep it simple, stupid. Don't make mistakes you're gonna regret. You can't make it look like you're a deceased relative. All right. Maybe I am. Let's see here. How's that? Wait, is that showing up live? It is. Watch the video witnessing. Did you send it to me? I don't know if I saw that you sent it to me. Trying to fix my, whoa. Okay, saturation has to be minimal because otherwise, on Instagram, okay. Okay, I think I'm blue. Da ba dee ba da da do da ba dee da ba da. Okay, orange. America is a great country. No, 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 no. Green. I'm gonna steal. I'm gonna steal Christmas. I'll go pink. Why the hell not? I'm pink. That's pretty good, right? I'm like a pink weasel. Okay, I am making a lot of sacrifices here. Green looks like the Matrix, but we're not in the Matrix. We're in the pink tricks. It's the pink tricks. Oh yeah. Welcome to the pink tricks. It's your boy Will from Dragonland Dynamics. I know that that arc was originally part of it. Bring that back. Tangent arc. Hello. Oh, I know. Drinking pink lemonade or pink grapefruit. Rosé tricks. I like that. Is this right? Where's my... I mean... That seems pretty... I think I'm missing something here. There's probably... Okay, I need to get the base bracelet back here. There we go. That's the shape I'm looking for. This is why I save all the old bodies, because information can get lost. Is this how your camera will look when the session starts? No, I think I'm gonna use my laptop for that. that would be distracting. This is just for fun. And it's also not on purpose, but it's just for fun. So shit. Did not want to merge those bodies together. Okay, that's good. And now I was going too much for comfort, and that's just like, come on, dude. I don't think we need to try that hard. It's not that uncomfortable, you know? Okay. All right, we're back to a little bit later. Now these things can slide past one another. Well, and I don't have to deal with all that other shit. Okay, so now back to the guides. Linear guides. Do you think virtual fusion is worth the effort? So I've used a few different CAD softwares throughout my life. SolidWorks, at least the ones that I've used extensively. SolidWorks, and then in my internships I used what was called PTC Creo, which I forget, maybe it's called something else now. I remember that one. It's not very common, but it's very common in like industry. And then I've used Autodesk Inventor as well, especially in my original high school engineering courses with Project Lead the Way, which is an engineering curriculum that exists in high school, which I think is very cool. But I only took one class, and then I helped teach some of the other classes. And then so that used Autodesk Inventor. It was like this is like an older version of Inventor, like 20 2014, something like that. And I also remember like using Inventor in that class and being like, oh, I want to get this on my like laptop, you know. And then I remember looking like for Inventor and being like, oh, they only have Inventor Fusion for my laptop. And I was like, what is that? And it was this free thing that wasn't very powerful. And then I remember around 2018, that turned into basically like Autodesk Fusion 360. Now it's just called Autodesk Fusion, but I still say 360. I quite like Fusion. I feel like it's the most like intuitive, but also more lately they've put in some updates that make it more similar to like SolidWorks and Inventor, where like the assemblies and the parts are separate types of files, but they still have their original type of file called hybrid design. So, and I really like hybrid design because you can have parts, multiple different bodies, multiple different components, and they're all native to this file. I that just works better for me than having to keep track of all the parts and then putting those in all the assemblies. It's not like very conventional, you know. I know that's not how most of these softwares work, but I really like it. I think it's way more efficient um, to design things this way. That's just my personal preference. So if I were to say, if you're already using Inventor, but I also don't know, Inventor Professional sounds like maybe something that didn't exist back when I used Inventor. So, you know, maybe that's like incredible. I don't know. But just switching from Inventor to Fusion, um, I would say, it's worth it because you can also do, like I said, you can now do things in a similar way where you have the parts and assemblies being separate. But now, I just really like the hybrid designs. I think that's just like it's very unique to this software as far as I know. But I'm also at a place where like I know what I use and I stick with it, and I don't know much else about what's out there, you know. So okay, so we need to figure out how to get good linear guides. Ignore this for a second and ignore that for sure. So these two parts just need to slide past each other. And they need to be like pretty well constrained linearly. I don't want a lot of play here. So like the first thing that I can think of, I don't know. Let's see. I don't do this very often, but let's see if we can get some inspiration. I mean, these are certainly like what you would typically see in terms of linear guideways on machines. And I remember this like Yeah, I mean that's totally fair. Mystic Turtle says that's kind of where I'm at too. I've gotten familiar with Inventor's quirks, and learning a new workflow seems daunting even if it's smoother overall. Yeah, it depends like where you are. Like when I switched from Inventor to Fusion, I was like, uh, I was like, you know, 13, which is like very pliable brain. Like you can, you're still learning things. Yeah, it just depends. Depends where you're at. Like if you think that you are really good at Inventor, I wouldn't switch. I would just keep that. And it is also annoying, like um, in high school we used Inventor. In college we used SolidWorks. So I got really good at SolidWorks. I'm a certified SolidWorks associate. But then for my personal projects, you can see my videos going back like forever. I've always used Fusion. And then even in some of my, most of my research work in college and grad school, from, if it didn't have to be like in a certain, like if I didn't have to adhere to someone else's project and like contribute to their CAD repository in SolidWorks, I would just use Fusion. Like if I needed to prototype something for a research project, I just use Fusion. That was just like so much easier. Um, just faster, and I'm not gonna like not use the fastest way. That's like I'm all about speed, basically. Um, yeah, so it's just like it's personal preference in my eyes. Like as long as you don't have to, it's good to know kind of how to use all of them, but especially if you get a job and then a certain one is required. That has happened to me before. And it's always annoying, but you can't really argue with it because it's true that, if people are working on the same project, they should use the same software. Yeah, so we got some interesting shapes here, right? Now, obviously, I can't use bearings, and there's not much point in using bearings. Like, I don't have space for linear guideways. I could maybe try to construct some little tiny guide wheels, but that seems like it would just take up too much space, unless I have the extra space, I wouldn't do that. I'm mostly thinking about these types of shapes. Common guideway geometries. So we're probably looking at guideways with sliding friction. So these exist in like machine tools, like mills, lathes, that sort of thing. So if you can see in this picture, gravity going down. We learned all about these in my at University of Michigan mechanical engineering 481, which was headed by my future PhD advisor, Albert Shee, when I took it. And then I later helped teach the class as a grad student instructor with Professor Dan Cooper. These are all manufacturing faculty. Um, really great class to have and to teach because we learned all about all the different manufacturing processes that you could possibly think of, you know, at least a little bit. And then there were some hands-on projects, as time went on, focused more on additive manufacturing. Um, but one of the key things is like the elements of a machine tool. And one of the key elements of a machine tool are guideways like this, linear guideways. So you've got a few different geometries. So you've got round, those are your, guide bars. You'll see that on a lot of 3D printers now. Flat, used for alignment only. So that only constrains things planarly. And typically that's like sitting on top, just gravity. So the only one here that is really, the only ones here that are really constrained are round, dovetail, and box. So those are all sliding ones. And you've got the ball or roller ones, which are using the bearings. Those are really nice to have on bigger tools, but I don't have the the space for that in this little bracelet. So like I'm really thinking about dovetail. Dovetail to me seems to be the way to go. Like it's standard. Yeah, let's see. If we can just fit dovetail in here, that would be kind of sick. But what has to go in here? We know the motor is going to fit over in this side. We know that there's going to be a pressure vessel here. And that's going to be made out of aluminum. So maybe the dovetail can even be part of the pressure vessel. And that's really nice because then we get an aluminum surface, though it's not going to be super easy to machine the sharp edges, but we can truncate the sharp edges, so it's not a big deal. If the dovetail is built directly into the aluminum, then you get a really nice smooth interface. Yeah, I think that's going to be good. It's got to be dovetail. I really can't think of any other way to do this right. So what I'm going to do, construct, plane along path, this line here. So now we're looking into the direction of linear motion. We're going to project this feature and that feature. And we're going to draw a dovetail. But I wonder, has anyone done any like dovetail guideway geometry? I'm not going to look at the AI overview. Measuring and designing dovetail slides. So this is talking about the machining of it, right? Oh no, they're talking like these are gauge pins. So that's for measuring after manufacturing these dovetails. They need to measure them, to make sure that they are of like really high precision because you need no play in these. And that's what I need too, but I'm not going to be able to get high precision with my manufacturing at my disposal. So this doesn't really give me that much info. But like, what is there a research here, right? These are about dovetail bits. So that's not super interesting. I'm going to go to Google Scholar because I want to look at research papers. Wait, let's go to my Google Scholar first. Nice. Look, it's my Google Scholar. Cool, man. That's so funny. I have 92 citations. Wow. Okay. Anyway, we're going to look for, what are we going to look for? Dovetail geometry. Dovetail guideway geometry. Optimization, I guess. Turbine blades, yeah, grippers, conventional lathe, multi-body vibration analysis. Guideway design and construction. The city of Atlanta is in the midst of a massive expansion at Hartsfield-Jackson Atlanta International Airport. This is from 2009, including an automated people mover moving on a 1.5-mile long overhead guideway and linking the main terminal with an off-site consolidated rental car facility. The system includes 2 terminal and 1 intermediate station and an elevated maintenance and storage facility. The city elected to procure the APM through the design, build, operate, and maintain procurement method. The design of the system was constrained by the performance and aesthetic specifications set by the owner and clearance requirements for the major facilities crossed. The structural design was developed by Archer, Western Health, and Lineback to produce the most efficient solution to the various constraints and to maximize the strengths and expertise of the construction company, and led to a unique solution, including a variety of structural arrangements. The basic superstructure type is a simple span, single cell, precast, pre-stressed concrete box beam. The deck is cast with the box, and the deck edges follow the curved alignment of the guideway. The webs and bottom flange of the box are corded to fit from pier to pier. Several spans had to reach an excess of 120 feet, and in these locations, the box beams were stretched, increasing the amount of pre-stressing strands. The lifting and shipping weight had to be limited to 250,000 pounds. However, so lightweight concrete was prescribed for spans in excess of 120 feet to a maximum of 140 feet, spans in excess of 140 feet up to a maximum of 165 feet utilize steel tub girders designed to the same shape as the precast beams. Several of the spans were in tight horizontal curvature. At these radii, it was not feasible to maintain the concept of cording the spans. 2 or 3 continuous spans of cast-in-place post-tensioned box girders were detailed for these locations. The typical substructure element is cast in place with a single column pier and hammerhead cap aligning with the box beam soffit. I don't know if there's going to be much here for us. I'm going to go dovetail guideway angle. Okay, so here's the issue. Dovetailing is, a common thing in woodworking as well. So they use very steep angles, but I know that in the machining, great, okay. If you were making a slide of some kind and were able to choose what angle to put on the dovetails, what factors would you consider in making that choice? Someone said 45-degree. Keep it simple. One of the most common angles for machine slides appears to be 55. Someone says 45. This one says 30. The shallower angle better able to keep a slide position when a force is making sideways against it. 90. Square slides. No. 60 degrees seems to be the winner for overall general use. The theoretical ideal dovetail is 55 degrees for metal. For wood, 80 to 83 degrees. the weaker material, the shallower the taper. They also said they haven't found that section in their edition of the Machinist's Handbook. So that's interesting. It's funny, all of this shit is from 2009. People were really concerned about guideway design in 2009, and not so much lately. 60 degrees is a lot nicer than 55 to work with. Okay, I understand that, because you can make a 60-degree reference pretty easily. Against side forces, only a single side of the dovetail opposes the force. Yeah. Against straight upward lifting, both sides. Tilt, however, puts the lifting load on one side through, though that slide then has some leverage against the other. For downward force, 45 would be weaker. At 45 degrees, the throat is narrower. 60 degrees usually lets you keep more metal where you need it. "60 degrees will exert more spreading shear force when lifted, but the sides won't be as badly undercut." I get it. Okay. Why don't we go with 60 then? 60 degrees. So basically, I believe what they're saying, the weaker the material, the shallower the taper. Six easier to scrape. Okay. Let me just take a look at some of the images here. So it looks to me that they're talking about the angle, from the ground. So let's go with 60. In which case, 60 degrees means we can use hexagon. Yeah. Pretty easily construct 60 degrees. Then we got to make all these equal. And then we got to make all these parallel. Okay, and then we got to do, these two are, no, not coincident. These two are horizontal vertical. These two horizontal vertical. Okay, and then we can do this one coincident with that line, this one coincident with that line. Okay. What is the problem here? Can we adjust this to be any size? We should be able to be doing that. Okay, I think we can. So if it's 3 millimeters, looks like this. And jury's still out on, which side has material cut out and which side has material added. We're also, of course, only looking at one of these here. And I also think to keep it equal, what is going to have to be here? There's going to have to be a ratchet. We do know that. And that's going to have to be probably in between. So we do need ample space for that somehow, which tells me that I would really like Fusion to stop buffering. They also say that this is for metal, which half of this is metal, right? Half of this is going to be aluminum, as long as it's machinable. And I think that the aluminum should probably be the one with the material added. I think. Okay. But it would really suck to mess that up in the machining, That would really suck. So I basically want these to be like symmetrical across this part. Don't mind me. Those two should be equal. Probably equal. Okay, so now can move these like this. Probably should be like a healthy distance from the edge. I'd say 4 millimeters. And maybe 3 millimeters is enough. Yeah, the aluminum should definitely be with material added because we don't want to eat into the pressure vessel. It's the last thing we want to do. Let's go 4. 4 millimeters. Okay. The issue is you're going to need a little end mill. You're going to need a pretty little end mill to deal with this. Let's not worry about the manufacturability just now, because it can always just be plastic. Maybe I'll prototype this now, and if it's plastic, then we should keep it plastic because, it would be dumb to not do that if it works well. I think. No pressure leaking. Absolutely not. Okay, I'm gonna go like this. And like that. New body. And here's what I'm gonna do. This gets cut with this body for intersect and keep tools. This gets cut with this body for intersect and keep tools. Wait, I fucking screwed that up. This gets cut with that body and this body. Got him. And this gets cut with that body and this body. Keep tools. Okay. And like I said, I'm pretty sure that we want it to be eating into this shape. Well, that's buffering. We love the buffering. See if we can find out more stuff here. So when they're talking about woodworking, there's a dovetail bit. It's like this thing here. And you can create these dovetails. And that's mainly, as far as I know, for woodworking, about attaching pieces together. Like this. Which is pretty cool. I'm not a woodworker, but okay. Then we combine this with this body and this body. And we got it. Really, really nice work. Okay. So now this one slides up to 5 millimeters up. And that means we're probably going to need to chamfer this. But we got to see. Because when this one slides down to -10, is that right? Is that 10 millimeters? No way. Okay, I got to do another 5. Okay. Woodworking class once in high school. It's more than I've done. Okay. Here's what I want to do. I want to fillet some shit so that we remain nice. Two millimeters. Is that too much or just enough? Do we still have good contact between these surfaces at 2 millimeters? This looks okay to me. This seems like it will still be quite constrained in this position, which is what we want. Okay. And we'll move it back to the max. So obviously here looks good. Although we probably want to fill it this and that, but not too much, maybe one. Okay. And then if we move this up to the max, which is 5, we get this, which still looks quite constrained, which is good. We probably want a little bit of fillet here, just because those being sharp surfaces could be uncomfortable, but we'll just add that for now. And we'll move this back to neutral. Okay, so now I think that's actually pretty baller to fit those guideways in like that. That's like obvious, like in hindsight. So, you know, why I did things over here the way that I did them. The guideways over here, you can see, are like this part against this surface and that surface, yuck. And underneath here, we've got this part between that surface and that surface, and there's so much play in that. I think dovetail is really going to make a difference here. I'm glad that I got my head out of my ass and decided that that was the way to go. I'm going to add a 1 millimeter fillet here, just because. And I guess here too, because why not? Okay. So I haven't accounted for any of the tolerances yet, like the space that's needed to create a running fit. So I definitely have to do that, but should I make the ratcheting mechanism first? I don't think so. I think I should account for the tolerances first. So I'm going to see what I can get away with by just messing with the surfaces. So first of all, here, I basically push back every sliding surface by 0.1 millimeters. It's sort of my technique. So first this one, that's supposed to be for the rotation. Good. Then we have everything that's here. Did I not fillet this? It should be filleted too. Okay. Dovetail redemption. This surface is sliding as well. I can't even see. There and there. What happens if I do minus 0.2? Okay, that works fine. Let's go with that. Okay. Then I do know that this is going to interact here. So minus 0.2 here. And I've got these surfaces here that are sliding past one another. This one, minus 0.1. That works. And on the other side, minus 0.1. Beautiful. Okay. There's some stuff here, obviously, that we just created. Start with the not dovetail surfaces. Okay, we're getting some problems here. Shouldn't be that much of an issue. Come on, man. Whoa, 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 whoa. Relax. Chill out. What did you miss over 62 minutes? We looked at dovetail guideways. That's what we're going to use for linear guideways here. I don't know why I didn't use them before. But maybe there was a reason that we're going to find out soon. I don't know. But I think that that's going to be a really nice sliding fit for the linear sliding parts here. Just have to make sure that we have adequate tolerances, which is what we're working on now. Let's see here. What I'm trying to do now is push back some surfaces after I've already filleted them, which is, you know, big brain. Okay, that works fine. What if we just work here? We're going to go this one, okay, good. This one, good. And now it's just this one and this one. Yeah, that works. See how that looks. I think that's that's everything. Good, that was easier than I thought. Okay, so typically I find that like for 3D printing, like a gap of um, 0.2 millimeters is pretty decent for a running fit unless you have like really big parts. And then a gap of 0.1 millimeter is probably good for a press fit or parts that are next to each other but aren't supposed to move past each other, you know, just to make sure everything fits. So yeah, that's typically my method. Great. So I want to add ratcheting now. I think that's the next step. And from here on out, we have to make sure to maintain these tolerances as best we can. And then we can put this thing together and try it. Now what's cool here is that I'm seeing an opportunity to release this mechanism with a single pinch, because if you may have missed it, my original design, had a ratcheting mechanism in the sliding to have that sliding be ratcheted, and then also a ratcheting latch between these two parts to secure the bracelet. I think that now is not going to be the right way to go. The best way, I have concluded, is a ratcheting mechanism here, like I did before, and a ratcheting in the hinge. And one of the reasons is those are so close together, you can see here, that uh, that you can have the release switch for one be right next to the release switch for the other, i.e. just a pinch, okay? And I don't want that to stick out a lot, because here, that was kind of one of the annoying things, is that this sticks out so much. It could also be somehow like a pinch this way. That could be interesting. But would that work? I would have to be able to pinch back. This is definitely the hardest part. Fabric lining and cam lock seems spatially efficient, however, a ratcheting mechanism is undoubtedly cooler. I mean, the problem that I'm running into with fabric is like adjustability, essentially. You're right that it would be spatially efficient, but I think that it can make the ratcheting spatially efficient, and then there's a way to have it lock, and that way, like the latching of the bracelet around your wrist, or the attachment of it to your wrist, and the mechanism that adjusts it to your wrist size are like linked together in such like a design efficient way that you won't need to account for those two things separately anymore. And it'd be nice for this to be a one size fits all, or one size fits most type thing. Yeah. Ugh. Just thinking here. Just thinking. Spring mechanism would be kind of cool. So first things first, I mean, we gotta get to the section view here, where the ratcheting is actually going to exist, which is on this surface and that surface. Easy, right? Um, and one is gonna prevent this from going up that way, and the other one is going to prevent this from rotating this way. Okay. I'm just going to like start sketching something out. So I think it would be better for like the quote unquote rigid parts, the parts that don't like that can't move away to release the latch, to release the ratcheting, should be on either end. So we're going to have static teeth on this part here and on this part here. And then in this thing, there's going to be mechanisms to have like the release switch and all that stuff. Because there's space for that in here. Whereas this is the pressure vessel and this is the circuit board. So that has to be in here. So static teeth. It's just like refresh my brain here. So this is kind of what we're looking for. For the circular one. And it's pretty common circularly, I suppose. And here's a linear ratchet mechanism. Seems pretty straightforward. And before I was doing like many teeth, like I do think like a little layer of foam padding will probably be what happens, yeah. But yeah, before I had like many teeth ratcheting like this, but as this shows, like I really only need one, but it has to be pretty like mechanically robust, you know, so the teeth can't be too small because 3D printing, I'll probably end up using SLA for this. I'm going to be honest, because having that sharp tooth is so much better for the survivability of these mechanisms than something like the minimum radius that FDM printing can make is basically your nozzle diameter and a little bit bigger than your nozzle diameter. So we're talking about like probably like close to a millimeter, which is not great. So once again, we want static teeth on these. And it does kind of look like, let's start with the circular one. So it looks like we've got like spirals here, essentially, like a bunch of different spirals built into a circle. That's what it looks like. Spirals. How do we make a spiral again? All right, I'm gonna do my method for making a spiral. I don't know if there's something easier than this, but you guys are about to witness something pretty fucking stupid. Okay, let's get rid of this sketch. We're not making anything yet. Oh wait, I just undid all my... Okay, I'm orange now. Sorry, I was undoing in the wrong window. Hope you guys like the fact that I'm orange. Okay, undo, 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 undo. Okay. What I'm gonna do to create this spiral, I'm gonna make a coil. Place that coil right there. triangular external. And we are going to have an angle. Something like this. Only to deal with one revolution. MTV interview for creating web if this was set in the 2000s. This is set in the 2000s, right? It's not 2026. So I think that in general this is a pretty decent spiral. If we go for 1.1 millimeter, then we're getting pretty close to a nominal spiral. It's just a matter of how often we want to ratchet this. So I think we should do an angle a little bit more. 30, 40, 50, maybe 50. Call it new body. Okay. The early 2000s, yes. The aughts. It's not like we're in the 3000s or the 1000s, right? Now, I was born in the 1000s, if you can if you can believe it. I don't know what that is. I don't know what configuration mode is. We're not going to worry about it. Diameter of 20. Okay. I'm going to talk about diameter of 20. What's the most we can do here? Looking at a diameter of maybe 10. Let's go with 10. MTV Downtown was airing. That show was a banger. Dang. Okay, 10. Okay, and then new sketch here. I made this over here, but I didn't mean to. Okay, let's just make this all construction. And I'm going to do a project. Get rid of this body. Then we're going to take this, copy, paste from here to here. That's a bit much. finish that sketch. Let's go back to the coil, reduce the angle a little bit. Let's go 35 degrees and watch what happens. Did that actually change? Doesn't look like it. Just made its own thing. Gotta move it again. There, okay. This seems more reasonable to me. So we've got a spiral. Yippee-ki-yay. I suppose then that then it's just about building these teeth out. Oh, it's buffering. Love that. I love that I'm being a lot more intelligent here with how I'm constructing this ratcheting mechanism and being like, there's teeth and there's a spring. You know what I mean? I feel much better about this. So, gonna make that a real thing. Gonna make this a real thing. And then it's just a matter of how many teeth we want, or what kind of angle increment we want to be able to do. And I feel like okay, we're not going to be able to get away with is 2 degrees too much to ask for? I feel like we've got to be a little bit generous here. I feel like, okay, we had that 4-degree increment. Why not 4 degrees? Not 4 millimeters, 4 degrees. Shh, come on. 4 degrees. Damn, that's a tiny tooth. That's a tiny tooth. Longest handstand. You know, the goal didn't get reached, so I guess I won't do it. The idea was 1 minute. But I guess I won't do it. You know. I haven't started a new goal. So, yeah, it was 610's suggestion. Damn, 4 degrees. 4 degrees is kind of crazy. But 4 degrees is what allowed me to get a little extra zhuzh. You know? But can I really get away with, like, a surface? Like, what surface is this? 0.1 millimeters? Like, I'd have to use SLA for that, and even then it wouldn't be that strong. You know? Yeah, next time. Next time we'll get it. Next time we'll get the goal. And I'm going to practice my handstand, too. Now I'm kind of afraid of having a goal set when Shadow is in the chat, because he's gonna make me do it. I've got to make the goal to be like $1,000 or something like that, and please do not meet that. Please, that's ridiculous. That goal is coined. So what if, like, maybe to start 10 millimeters. If you can do it, so can I. Maybe. Maybe. So these teeth, what are they really accomplishing? 10 degrees. $10 degrees is maybe a thing that I could do. Symmetric. No. From object. This object. One side. Let's get rid of this here. All the way to here. New body. What is that? Why is it sticking out so much? Oh, to object. There. Hello. Get rid of all these bodies here. I need to see what I'm doing. Wait a minute. From here to here. Okay, easy. So there's a new body, and we said 10 degrees, which means you're going to have 36 of them. Now this is something I don't think FDM printing can do, but that kind of comes at a perfect time. That is, if SLA printing can do it well. Like, come on, how much strength do you really need to hold something like on someone's wrist? You know, like how much could you possibly need here? Okay, really? We're gonna play it like this. I'm gonna have to select all of these and then go combine. Yeah. I don't think FDM can do this. 8 pull-ups, but I hate that it's a one-time thing after I'm pull-up control. Do you mean like right after that? I mean, of course. Like if you're doing your max pull-up rep, like, and then you try again, it's gonna be less. Like for me, I'll typically, like right now, my max is like 15, and then like immediately after that, I can only do like 6 or 7 at a time. You know. Okay, so here's what I'm gonna do. First of all, I'm gonna copy this. I'm gonna call this ratchet wheel, so I can keep that for future reference, so I don't lose it. Then copy it. I'm gonna combine this and that. Not that, just this. just as I thought. Okay. So it seems to me we've got a couple of teeth here that will not be used. This one, then that one. We'll cut those away. Okay, and so begins the bullshit. Let's try to do this a different way so we don't end up with weird surfaces. We're going to do this and keep tool. Then we have the teeth and the thing. And then we just get rid of this and that and this and that. Whoa, okay, maybe not that one. Okay, so those are all the teeth we want to use. Oof. My head hurts. I need some water. Goodness. Let's get rid of that. Let's get rid of that. Copy and paste this. And that and that together. Please look good. What do we... Huh? Oh, I understand. Sorry. Complaining for no reason. It's the ratchet one. This is the base one. Let's put that up here with the base bracelet. Okay, great. Motor section, base, and rename this one sliding bracelet pressure vessel base. Just make sure I keep track of all the steps here, especially now that I'm starting the ratcheting. I don't want to lose any of my information about how I design things to start. And I kind of think, what is the rest of this stuff here? Oh, ratchet wheel can stay, of course, because that's one of the steps. Spiral, get rid of that. Motor can stay. Why so thirsty? That's fine, complain. It's part of the process. Okay, I'm gonna get rid of this. Don't care about that anymore. What would really be cool is making this ratchet stuff out of metal. good. That one. And that one. I think can both go away. Okay. Let's look at that section analysis again. Okay, so now got teeth. And those teeth are facing the right direction. For a minute there, I was like, oh shit, they're in the wrong direction. But they are. Because this is to prevent counterclockwise rotation. Okay, I'm going to get some water. I'll be right back. So we got these really little teeth. And that's always fun. And I guess where like the ratchet thing actually lives will be determined by like everything in here. But let's make the other side of static teeth now. And we know, like, I don't think we're going to be able to get teeth much smaller than this, to be honest. 0.4 millimeters. It's not like stupidly small. It's just pretty tiny. Like, that's your line width for FDM. So this is definitely going to have to be LSA. LSA? College of Literature, Science, and the Arts. No. SLA, stereolithography. Okay, so here's what we do. Static teeth. Everybody knows it, everybody loves it. Static teeth. There's a couple of reasons for this to be SLA as well. The dovetail precision is one of them. Not all the parts. We're going to be using a combination of SLA for precision, FDM for strength, and machining for pressure containment. So to make them kind of similarly sized teeth, you know? Which means 0.415 off the surface. And how far apart are they is the next question. .876. Okay. That's the tooth. And that's the tooth. 0.876. I'll just make a little base for them. Like that. Okay, and then we're going to extrude a single tooth. All the way to here, we're going to make it a new body. This is facing the wrong way. I'm now realizing, but that's okay. Because I have the power of three-dimensional geometry at my disposal. And what that means is all I gotta do is draw a big ass line right here. Draw a point. Wait, what am I doing? There's no reason for this. Just edit the sketch, bro. You just finished the sketch. Come on now. It's that simple. Okay. Bing, bong, boom. Wait. There we go. Okay. Don't do any of your crap. Come on, Will. All right. Then we're going to do a rectangular pattern. This one. That one. Yeah, dude, you got it. Come on. So it's going to be like here. Oh, I guess I could go all the way. Let me go 16. What is happening here? Axis. There. the hell are you doing? What the fuck? Okay. We need extent. -16. Wait, we need spacing. What was it? 0.876. 876. Not 976. 876. Okay, that looks right. Then we need, what, 16 of them? 17? 18? 20? 20 looks about right. We're going to do ratcheting right for the first time in my life. It's actually going to be so good. But I just spilled water everywhere. We're buffering again. There we go. So now I'm selecting all these things that I just made, and we'll make them one body. Then what I want to do is I only really want this in between these dovetails here. You know what I mean? That's sort of what I'm thinking. There we go. Okay. This is going to be called ratchet surface. Quit being ratchet. Okay, ratchet surface. And that can go up with ratchet wheel. Then we take this, combine this. No, we gotta copy this. Pressure vessel ratchet. Combine this with that. Wait, keep tools. Oh no. Oh no. switch these around. Okay. Now we have the both of those static wheels or static teeth on the surfaces there. I love it. It's great. That's what we want. Now what next? They probably won't be built into the pressure vessel because it's difficult to machine those at low cost. And I think they're going to be SLA. And then maybe the dovetails will be SLA as well. They're going to be attached to the pressure vessel rigidly. I don't think it's a good idea to machine them directly into the pressure vessel. But hopefully, like, I really don't want to take up too much space of the pressure vessel, obviously, you know. Okay. We need a little bit of spacing going on here. So first thing, new offset 0.4. That will probably be good. And so 0.5 is what we're going to go for, okay? After we're done buffering here. Yo, I can't believe it. It's 2:30 p.m. But we're so close to just having this bracelet. That's what I wanted to do. That was step one when I sketched all this stuff out of how I'm going to reconfigure this web. Number one, design adjustable bracelet reasonably, and then two, fit everything else. And fit everything else shouldn't be too bad, you know, given I've really accounted for a lot already. Yeah, that's right. You're almost clocking in. 4 o'clock. Okay. So we need to offset this by 0.5. Unconstructify it. And we use that to cut this surface here. Wait, cut. What? Oh. There we go. I guess we could just do this. Okay. Great. Go back to this section analysis, and yay! Bing bong, boom bom, bing bong, boom bom, bing bong. Great. Good. We got it. 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 Great. Okay, I'm excited. Now the more difficult part. The moving parts. The parts that go click, 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 you know. We're buffering again. I hope everybody's enjoying the buffering. Great. Now, parts that go click, click, click. So let's go back over here. So this is just a simple rotating thing, and I think that's going to be pretty reasonable. But then the question is how to like separate this. If I'm being honest, I think the best way to do it is laterally. I'm not gonna lie. I think the best way to do it is laterally. Huh. I'm pretty convinced of that, to be honest. Anything we do is before GTA 6 at this point. Didn't they just release a bunch of stuff about how they're basically like trying to like way overcharge people? Click, click. I think it's gotta be laterally. In which case I'm gonna need to get some segments in the teeth. But first, maybe I should do the pawls first. Just create the pawl geometry first and then edit it so that I can have the release mechanism. The pawl, by the way, is this pink part here, the one that's moving, and then the ratchet is technically the wheel. At least I'm pretty sure. I could be wrong. Yep. Oh, the ratchet is the whole thing. Gear and pawl. Well, here they call it ratchet and pawl. Right. Zone back at GTA 6 mention, I'm 100% certain. It's going to end up like Cyberpunk and be glitchy on release. Damn, that sucks. I never played Cyberpunk. Fortunately, I'm not a huge gamer, and I'm ashamed of it. Okay, Paul first. Jake Paul, Logan Paul, doesn't matter. Just make the Paul first. No. Oh, yeah, wait. Now we're going here for projection. Look like tiny saws. Exactly. I gotta do this as construction lines here. Not this one. Here, here, here. Yeah, here, here, and here. That's the geometry that I want to see. And if we now get rid of the bodies, we can see everything at the same time. I mean, honestly, I want to isolate this. Oh shit, we can't see any of the sketches. Just gonna make all of these go away so I'm not distracted by them. Okay. Lots of stuff going on here. Almost the fact that like that makes like one of them is going up and one of them is going down makes me feel like I like could do something. Wait, but they're both going down. This one will flip up. Yeah, no, that's not gonna work at all. Never mind. Great. Okay, let's see here. Just need Paul's. But there's so much space here for them. That's what makes it tricky. Like this isn't like constrained, you know? Sometimes like mostly it's like offset. Let's think about it like this. We have this line here, here and here. I want this to be like in the middle. No, not the whole thing. Chain selection off. No. Chain selection off. Okay. What's in the middle? Like this one. Should probably do this one though. Okay. But then there's not a lot of space for it, so up high is better. Let's do that. 0.05 clearance. Similar thing over here. Hmm. Hmm. Thinking I want one at, like at a similar angle. You know? It looks like this one to me. There's certainly space. So draw a circle here, draw a circle here, make them the same. Shrink them down. Shrink them down. Oh. Just forgot a dimension, whatever. Probably 4 millimeters. Maybe 5 is better to be safe. Okay, and let's just say increase this 1. That's 1 millimeter. It's a lot. 0.5. Why is that red? I think this one needs to be more over here. Yeah, sure, whatever. This one's better. Probably. It's like here. And then we make this 4 millimeters. This should be. Let's try 7. 7 millimeters versus 5 millimeters. I like that better. 5 millimeters here. That will be the actual shape of the thing. So we can deconstructionify that. Deconstructionify these. That should be good. But maybe we use an arc instead. Just to be safe. I like that idea. Tangent arc. Boom. Boom, boom. Oh, brother. Okay, I'll do the same thing over here. Tangent arc. Between here. Sure, whatever. And this one will just be a line. Okay, great job, I think. Let's give it a 2mm diameter shaft. You've got the paws, and I don't mean Jake and Logan. New bodies. Obviously, some problems here, but that's okay. We just have this and this. Like there. And oh boy. -10. Um, that is interesting. Suppose that these are going to be the same, right? I should just make them the same distance, the same thickness, the paws. Wait, are these the same distance apart just by happenstance? Yeah. That's crazy. Okay, not that one. Okay. It's a little bit of zhuzh. Mm-hmm. Mm-hmm. Okay, need more water, more brain juice. But that's what we got. Pretty nice paws, I think. It's just a matter of packing them in, space for springs, and space for the release mechanism, which I think I know what to do with. Yeah. Oh yeah. Oh yeah. Okay. This is going to be so cool when it's done. I can't wait. And I don't even get to wait. I have to actually do it. Okay. So the thing with these is that this one needs to be forced to rotate clockwise. This one needs to be forced to rotate counterclockwise. And not that much. So maybe this can be done with 3D printed leaf spring, which I love to use, but of course has its own drawbacks and dangers. And if I were to do that, I'd still need to constrain the rotation. That's a must. But would I need to... Nice. Nothing better than 3D modeling while watching a 3D modeling stream. Pretty awesome. Yeah. I still need to constrain the rotation. So then it's just a matter of, you know, how to get these to return to their desired position. Could use a constant force spring, which is essentially just a spiral, you know. The other thing is, gotta remember that I don't really need these to rotate past very much, past the point where the can happen. I'm gonna make sure to name these. Paul 1 and Paul 2. I feel like it's a missed opportunity if I don't call this one Jake Paul and this one Logan Paul. Morons. Okay. So that's really the extent of the rotation that I need. Let's just call it 10 degrees max, right? J and L engraving them? Oh my god. No, that's too far. I don't mean to call more attention to those dumbasses than they already have. Um, yeah, let's call it 10 degrees. And in terms of the space that's allotted these pawls, probably want to also give them space, even though they don't need to rotate this way 10 degrees. Even though they won't, obviously, but just so that there's space for them too. So that, like, just to make sure that that's not constrained, basically. Okay. Good. So it's really as simple as creating some force generating a torque that way, and this one generating a torque that way. Just thinking about what's the simple, intuitive way. So, like, if I were to do this with the coil springs that I have in stock, let me see what I got. Just thinking about this so I don't have to deal with, like, the headache of figuring out what geometry it works best for, like, a 3D printed leaf spring when coil springs are right there, you know? Boom. Probably can't see it because of the color, but yeah, got this one right here. Oh, dropped it. So this one, I'm going to find the length and diameter, see if it's feasible. I got a few of these. Calipers are in the other room. BRB. what will be used to unlock the ratchets? You'll have to see. I have a couple different ideas. Obviously, there could be something to rotate them in the way that I'm showing here. But I think there's probably a better way, mechanically. But I could be wrong. I could be really, really wrong. I'm thinking about, creating some space for them to move off the teeth in this direction here. That's sort of what I'm thinking right now. Okay. A button moves the levers that move the ratchets. Yeah, these pawls here may be the levers that you're thinking of. Move those front to back, and the teeth only exist on a certain plane, something like that. Okay, so we're dealing with like 19 millimeters. Distance between these pawls, 22 millimeters. So not quite long enough. Well, I could extend. I could extend. What's the shortest distance this could be? 5 millimeters? Okay. Honestly, could have 2 of these. I think this is going to be the best way to do it. I just need to construct the geometry and figure out. Yeah. Obviously, one of these is moving more down, one of these is moving more laterally. What's the diameter of this spring? 5.7. How long is this line? 6.4. 10 millimeter length of this spring generates a pretty nice amount of force. I like it. It's not too unstable. But it could be. Yeah, I know what you mean, man. It's so hard to get enough time these days. I'm pretty much working like I'm working on this stuff like 12 hours a day. From the time I wake up to the time I go to sleep. Let's see here. Okay, so kind of fits. Actually, those springs kind of fit. There's nothing else really that has to go in here. That's the cool thing. Space for wires would be nice, but I think we'll still have it. So 5.7. Mm-hmm. That's that spring. Okay. And that's the other spring. I only want one of these. So I think I only need one. You have a caliper. That's great news. Love calipers. think I'm going to redefine this plane. Midplane. Ta-da! They're now in the middle. So that's where the springs are going to go. Goodness me. Okay. Good. Okay. Make these springs a little bit wider to account for some of the sliding tolerances. 0.3. So those are going to be pushing down here. Then I know that we're going to need some space for those springs to slot into these pawls. Is that silly? I don't think so. That's correct. Probably want a wall thickness. One millimeter. These two perpendicular. Millimeter. Okay. Then we can probably just draw this line. Make that parallel. Okay. body. Just got dressed for work, gonna eat dinner. Good luck, my friend. Oh. Okay, and now we can cut, but keep tool. We can cut, but keep tool. Tobey Maguire. Okay. We need the other surface, you know, where the spring is actually going to be. Buffering. Okay, we need the, I guess, like the center part here. Just make another plane here. Make a sketch there. Blah 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 blah. I'm imagining this pawl stuff like an assembly of pawls, two pawls, and springs and release mechanisms that then gets, as a whole assembly, placed into this segment of the bracelet. That's kind of how I'm imagining it. Like you build the ratchet release assembly, and then you put it in the middle when you're building the thing. So once again, la 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 la. Why am I getting so tired? I think I need more coffee. I should probably make some coffee. I already had some coffee I should make some coffee. And then I could also have some food as well. When will the web be released as a product? I'm hoping before the end of 2026. I'm pretty sure. Um, but I have been known to promise a lot more than I'm capable of. Which is, the only way I really can achieve success, if you think about it. One other, oh, don't worry about that right now. Okay. Select, 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 select. Okay, sorry. What do you think we'll go for? Probably more than Charlotte. So probably list price, maybe, probably list price maybe 300, and then start with a discount at 250, something like that. Oh, what am I doing? Select this and that, and this and that, and this and that, and this. I guess, okay. Try that again. $10. Okay, now $10. Offset 0.1. Okay. So now we get to see how these poles are going to move to the max. That much, the orange lines. And do a 3-point rectangle. And again here. So honestly, we really could like if we make this line unconstructioned, this one unconstruction, most of the springs could just be like completely missing. Maybe just extend this 1 millimeter. One millimeter. One millimeter. that's tricky. Yeah. Yeah. Something like this. I need to see about this moving 10 degrees this way as well. This one I don't think will be a problem. Yeah. All right, let's go for that. Yeah. Okay. Okay, and then we just need to cut out space for the springs. Hold on, is this good enough? May want to take a little 0.5 there. Oh. Mm-hmm. Okay. So that's like spring and ratchet assembly. All right, nature calls. I'll be back. All right. Let's see here. Mm-hmm. Mm-hmm. This is 15 millimeters long. I think we're going to have to lose some thickness of this, which is not like ideal. What do I use to pressurize the fluid container? I use sometimes I use compressed air, and sometimes I use a refrigerant. Um, it's a lot more convenient, but um, it's pretty easy to test nowadays. Need some extra room here. We're gonna need to lose like, because we need the wall first of all. I don't know, maybe it would be easier to just have something to pinch these together. That might be better than having this slide back and forth. Yeah, I've been somewhat swayed. Could even be like a button. That'd be cool. Like a release button. Just, you know. That's a simple planar mechanism. We don't have to worry about anything else. I quite like that. But first, we kind of have to lose 2 millimeters on each side, I think. It's 15. I want to get away with an extra half a millimeter, because then we can use a 16 millimeter long screw for the pawl axles. Okay. We're buffering again. There we go. And then in this case, I really don't think we Need that much material over here. So I'm going to chamfer that. Nope, that doesn't work. Single distance, please. Hey. Okay, we'll use fillet then. Bleh. Just cut it. I'll cut it myself. Here, why not? Ta-da! Oh, shit. Do you have plans to do the rest of the Spider-Man suit? Or are you focused on the webs and Charlotte? How long have you been a viewer? That's the question I would have. And then the question is, like, my focus right now is not to build a Spider-Man suit. That's something that I've done, time and again. The focus is to create technologies for all sorts of rescue and RLSH operations. No weapons, only benevolent technologies. It's not difficult to create a Spider-Man suit. What I'm engaged in is research. Cool, man. No, that makes sense. You should go watch some of my old stuff. It's pretty rad, honestly. Will they ever update that RLSH Charlie found? You mean Skyline? The goat? Oh no, I didn't do that right. There's the axle. So this is like a Paul box, you know? Oh, the map. Will they update the map? Yeah, that's a good question. It all depends if they update the wiki. That's like Discordia was working on that, the wiki. Okay. So here's the Paul box. Now we have to find something that will allow me to push down and have these be released. Actually, that's pretty simple. That's fairly simple. Yeah. I think I know what it is. I think I know what it is. It requires a little bit of flexure, but not too much. Okay, this is so good. So let's say we want the button to be just straight up like a big square. I like that. I like big squares. Don't you guys? But there's a spring there. So negative 0.3 is the farthest we can go down. I shall chamfer because I'm a classy engineer. That's too much chamfer. Let's go 1.2. Okay. Then, where are the springs? Great. Then make a rectangle. Seems reasonable. So there's nothing here. Basically until like we get down to this area. So let's pull that. Negative 11. Yeah, I think that's definitely a potential application for Charlotte, for sure. I'm definitely interested in talking with firefighters, seeing what they think, what their opinions are. It's very important to me. Oh, shit. trying to think. I know exactly what I'm going to do here. I need to look inside. Yeah. So it's going to be a flexible member. Basically, And we're going to mirror this member to the other side. Oh, yeah. This is going to be good. Okay. We got to create this as a loop. Okay. Bye, 610. Thanks for stopping by. Appreciate it. Good luck at your shift. You can do this. I don't know how this happened. Somehow this is wrong. What is the consumer web going to be used for? What are you, a lawyer? It's used for whatever you want to use it for. Okay, now get these together. Get these together. No, I swear. Okay. More symmetrical. And sorry, what? Oh, okay, okay. I got it. Self-defense or RLSH or something. I would say yeah. Definitely. Oh my gosh, come on. No. Jesus, what is happening here? Okay, you know what? Screw this. I don't know why I bother. We are going to cut. Cut. Oh boy. Oh. Okay. Buddy, I'm gonna need you to log in. Come on. You can't be. Oh, what are you thinking about? Like when I say I want to do this operation, and then I say, actually, no, I don't. And then I hit escape. And then you're like, oh my God. That's why you don't personify your software, people. You end up like me, yelling at machines. Cut every single body in here in half. Get rid of that, get rid of this, get rid of that, get rid of this. Then, nope, not doing that. That one, that one, that one, that one. There. Uh-oh. That's the Paul house, this part here. This one, that's Jake Paul. This one, that's Logan Paul. This one, that's the Flex member. Oh. And get rid of the chamfer on one of these. Great. Now we're just missing the rest of this equation, which is a button on the top that will push down on this flexible part and cause these to flip into each other. Whew. But I will tell you, I'm losing steam. I'm glad nobody made me do a handstand, because then I'd be really losing steam. Okay, here's what we're going to do. Line here. To here. What are we doing? We are making the the ratcheting mechanism. Right now, the ratcheting release mechanism, because the ratcheting mechanism itself is already done. So the thing that will allow you to adjust and tighten this bracelet. Once the buffering stops, that is... Hello? Please, come on. I'm gonna fall asleep. Okay. Yeah, it's just what I thought. Okay. Make a little indent. Okay, and then over here, the same thing. A little indent. That goes to the wall. Then round those edges. You love to see it. Then okay, just make a new one. Okay. 0.2 millimeter plane away from that surface. Three 0.3 millimeters there. Yada yada yada. Construction line. Then a overall slot from here. This is the shape that's going to push down on that flexible part. Doesn't have to be too thick. I just drew a rectangle, bro. Like, why are you confused about that? I drew one singular rectangle. Okay? Okay. Okay. So this body that I just made here, this one, when we push down on that, it will push down on this flexible part here and cause the ratchets to, or the pawls to flip in on each other, releasing the bracelet. So we're going to mirror that body. We just need to make the rest of this button. 0.2 millimeter tolerance. I think -2 is all we're going to get there. Come on. It's not a lot. No, stop. Doesn't matter. This one can go down more. So I'll make it go down more. Okay. This one needs to go up more. Combine, 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 combine. Some extra reinforcement here. Then we do fillet, fillet, fillet. We got Chonky Bonky 69 in here. Holy cow. Holy cannoli. I didn't know that was even possible. It's like 2.5 degrees radius. Okay. Next, I'm going to press pull this. by 1 millimeter. Press pull this 1 millimeter. Just to give it a little extra beef. And then finally, get this square and this square 0.5. And of course, we're going to chamfer the whole top of it because we can, I think. Let's do that way. Okay, that's the release mechanism. Finished designing. Ooh. Oh no, that's the paw. Duh. Okay, then that needs to fit in between here. So if we, first of all, we take this, split it with that surface. I think that will still be fine. Right? Right? Fusion? Right? Please? Hello? 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 I'm about to call the police. Okay. Did that break anything? Shouldn't have. Nope. Okay, good. Then we got to take this one, split it here, and here. I'm gonna be honest, I haven't read that book in a long time. I don't remember it very well, so it's probably not super memorable. I learned most everything that I have from college courses. Okay. I'm already seeing a vision where these two indeed. Let's put this one here. So this, and this, and this, and this are now all one part. Big fan of that. We're basically just trying to get this latch releasing mechanism to fit inside the bracelet geometry that we've already constructed. And I think it's working quite well. Get rid of that. Cut that one with this. I do what? Oh, if not, do I have a book recommendation? It's been so long since I read a book about engineering. Let me go see what's on my shelf. Maybe we'll jog my memory. Yeah, it really depends what you're looking for. I think right now a lot of my books are not even there anymore. Because I'm moving soon, but like I've just got like random textbooks, stuff that I used in school, like fibers and composites and that sort of thing. You said you thought it was quiet, working well. Yeah, I think it's working well. It's coming along. I'm definitely losing steam though. I'm gonna have to log off in a second here. I've been at this for like 5 hours. Nearly done, but definitely need to eat and drink. So there's those two parts there. one can go away. Got the button. It's the release button. Motor section. Back. Guess I'm late. Yeah, very late. But that's okay. We're happy to have you. And this one, straight up, just go away. Okay. So that's the release button for the whole bracelet. And it looks like this. Not everything yet. We still need to design something to fasten this in here. But it's not bad. Only sticks out a little bit. And yeah. I'll show you guys, or whoever's here, basically what we've accomplished. Are these ratcheting mechanisms with springs that will allow the bracelet to be both adjustable and latchable, and both of those, adjustment and latching, to be released with a single button. Missing a couple fasteners, missing a couple springs. Oh, that's a good point. The dovetails don't have end stops. That's another thing. Thank you. That's pretty good. Yeah, but that's pretty trivial. So definitely need end stops for the dovetails. Yes, very good. Very good. Very good work. Very good work, Chonky Bonky 69. Good stuff, I'll say. Okay. Yeah. But definitely pretty happy with this work. Just a couple details to iron out. And definitely much sleeker than the bracelet we had before. And everything, I've already accounted for everything, is going to be able to fit inside this body here. So we're not going to have any more, random little mechanical happenings poking out. And that's about it. So thank you everybody for coming. I need to eat some food, and I appreciate all of you, and I will see you guys in the next one. Stay amazing and stay